Test will cover up to lesson 40. Test Friday. So that'll go. So test 240 on Friday.
No, I think you just hit yourself up for today.
All right. I apologize for the short notice, but there are lots of tests in this class, so I'm not too worried about it. Okay. Any problems from 43 that you want to go over? Please. There are problems here that covered anything up to and including lesson 40. Let's 5. Please stop the tapping. Thank you. Would you please put your sport coat on?
Me?
Yes. Please put your jacket on. Thank you. So 25, we're going to need to do in a couple of steps. When they say evaluate, they mean find the value of. Pipe, M, pipe, minus, parentheses, M minus X.
No, what got me was it said M plus 3 equals -2 and X equals 3. That makes me up.
Yeah. Shh. You be quiet.
You got asked to be quiet, bro.
M plus 3 equals -2 and X equals 3. Okay, so now in order to find the value of this, because it's not an equation, we need to the value of our variables. Well, they tell us what X is, but they don't quite tell us what M is. They don't tell us what M equals, they tell us that M plus 3 equals -2. So what's M? If M plus 3 equals -2, what's M?
1.
No. Thank you. Yeah, because we subtract 3 from each side. M plus 3 is -2, subtract 3 from each side, M is equal to -5.
Okay.
Then we just plug these in. So instead of M, I'm going to write, well, I don't need the parentheses here, because there's already parentheses, minus -5 minus 3. Okay, 5 minus -5 minus 3 is what? It's -8. 5 minus -8 is what? It's the same as 5?
-13.
No.
5 minus, oh yeah.
5 minus -8 is the same as saying what?
8 minus 5.
No.
5 minus.
Minus a negative is the same as?
5 plus 8.
Thank you, adding a positive. The negatives cancel out. It's 5 plus 8 or 13. There you go.
That's not what you said.
That's what I meant. That's what I meant.
All right.
Yeah.
Next up, other ones you want to go over? Especially
Number 24. I mean 25, 26.
20 what?
26.
26 is the same kind of deal.
Yeah.
I want to prioritize problems that are from 1 through 40 first. We can do 26 if there aren't questions about any of the other ones. So below the number of each problem, it says which lesson it's from.
Oh.
That's a nice thing that they give you. So if you're not sure how to do a problem, look at that little number and it'll tell you what lesson.
You said have a look things on the test.
Can you
Like
please
back
do
and look.
6?
Number 6.
Let's have a look things on the test.
Yeah, number 6. Let's do number 6. Functional notation. Don't let it trip you up. So they say f of x equals -3x squared plus 7. Then they ask us to find f of -3. What does it mean when we have
3 where X is.
right? Doing the operation f to x, for the purposes of this problem, doing f to x means to square x, multiply by -3, and then add 7.
Doesn't it actually have a function?
Yes.
Function.
I saw a thing on Facebook last night. Student, can you at least curb my grade? Teacher.
Oh wow. Oh wow. Oh wow.
I thought it was pretty funny. All right, so yeah, so here doing operation f to x means to do this to x. So to do the same thing to -3 means that instead of having x in there, we're going to plug in -3. -3 times -3 squared plus 7. You see how I did that? All that I did was I replaced x with -3.
Oh.
Because doing f to x is to do this. So to do f to -3, wherever there's x, we replace it with -3. Then we do our exponents. We get -3 times 9 plus 7. We get -27 plus 7, -20.
Oh.
That's functional notation. Functional notation is not difficult. You just have to be familiar with it.
I put like -3x parentheses. Or no, I put -3x squared parentheses -3.
Oh yeah. So you should be replacing the x's with whatever the number that it is there. How do we know to add parentheses? You should always be adding parentheses, especially when the value that you're substituting is negative. Because, so for example, right, let's say it's x squared. X squared means whatever the value of x is, we're going to square that. So if x is 2, okay, 2 squared, that's 4. But what if x, doing this without writing the parentheses, doesn't mean taking negative 3 and squaring it. This means square 3 and then make it negative. So if what I'm supposed to be doing is taking whatever x is and squaring it, I need to make sure that as a note to myself, I write parentheses around there to make sure that I square the whole value of x, which is negative 3. So anytime that you're substituting value, you have to when they're negative values.
Wait, I have a question.
Yep.
If I had 2x squared and another 2x squared
What's connecting them?
Nothing.
plus,
Okay.
can I just make them 4x squared?
Yep, because these are like terms. Yep.
So if you had, actually, wait, oh yeah, I know you do.
Because they've got the same variable with the same exponent.
Would it be 4x?
No,
Okay.
because they're being added.
Okay.
If they were being multiplied, then here, let me use a different example. Let's say it's 3x squared plus 3x squared.
Okay.
Whatever x squared is, we've got 3 of them here, and then we're adding another 3 of them.
Yeah.
So now how many x squareds do we have?
6.
6 of them. We've got 6x squared. It's different from this. 3x squared times 3x squared is
9
It-
x to the 4.
right, is 9x to the 4th, because that's 3 times x times x times 3 times x times x.
What?
Right?
Yeah.
Yeah. So it's 9 and then x to the 4th. So be careful. Here we're adding like terms. Here we're multiplying. We're allowed to multiply together things that aren't like terms. It's sort of like with fractions. It's actually very similar to fractions. Okay, other questions from the problem set that you want to go over?
35.
35. What?
You don't
Number
have
35.
you're slow.
I mean, 17.
17, okay. 17. Oh yeah. We're factoring out a Gray's common factor. No, he's because it's from less than 35. X to the 4th y squared m minus x cubed y cubed m squared plus 5 x to the 6th y squared m squared. What is the biggest thing that we can divide out of all 3 of these terms?
What?
We're looking for the greatest common factor.
Oh, greatest thing. No, x6.
X
That's
to
the big
the
problem.
X to the 3.
X to the 3rd power. Why x to the 3rd power?
Okay,
Because the lowest X is 3.
Right. When we're looking for the greatest common factor, we're looking for something that we can divide out of each of them.
Yeah.
So it can't be larger than the smallest thing.
Yeah.
It's easy to divide x cubed out of x to the 4th or out of x to the 6th.
Yeah.
But we can't divide x to the 6th out of x cubed. We're going to end up with a fraction. And that's just going to make our lives more difficult. Yes?
Will it?
Wait, we're not gonna have this kind of multiple.
Least common multiple, no. So x cubed, what else? Not just x cubed, but x cubed, y
Y squared.
squared, m, what?
M.
Just m, because we have m in the first here. Okay, then what does once we divide that out of each term, what's the first term going to become when we divide that out of there?
X minus
X.
Just x.
minus
Minus.
Y squared.
Minus what?
Y squared.
No.
Y squared.
No.
Bro, like, why do you keep saying this?
Why?
No. Yes. Yeah. Y.
See, that's what
X minus y, right? Because x cubed divided by x cubed gives us 1.
Y. No. M.
Yeah, 5x cubed m.
Wait a minute.
You wait a minute.
Oh yeah, no.
I'm waiting for you.
Any others?
That one.
Which one?
Bro, shut up. You're walking. Why do you do this? Why?
Any others? You still want me to go over 26?
No.
Do you still want me to go over 26?
Can we go over, let's see, like,
16.
oh, can we go over 30? 'Cause, like, I was-
Number 26. Oh, no.
What was the other one mentioned? 16?
Yeah, I didn't.
Yeah.
The 16 works the same way that we did this one.
Like, can we go over 29 and 30? 'Cause
I didn't do those.
Yes, let's do 29 and 30 really quickly. These geometry problems. Listen, you should have figured this out by now. Every single one of these tests,
All the formulas in
the last one or two problems are geometry problems.
Yeah, we know.
So you just need to learn how to do these. So I'll do them right now.
All the formulas in the back of the book.
Yeah, well, they should be in the back of your brain also.
Are they?
No, they're not. That's the problem.
Dang.
We need to get them there. There aren't that many of them, and they aren't very complicated, and you're using them frequently. Listen, we've been using these same formulas, some of them, since the very beginning of the school year. All right, now, so 29, we'll find the area of a parallelogram. How do we find the area of a parallelogram?
Base times height.
Yes, base times height, or length times width, whatever you want to call it. What's the base of this parallelogram?
24.
24 what?
24 inches.
And what's the height?
5 inches.
5 inches, so what's the area?
The area is 120 inches squared.
120 square inches.
Wait, I could have actually done that.
Yeah.
I don't know why I didn't do that. That's what I thought, but now I'm like,
Yeah, parallelogram is just length, base times height or length times width, whatever you want to call it.
I was gonna be wrong. So why didn't you do it?
That's a big top.
30. What are they asking us for?
Surface area.
Surface area. What's our formula for surface area?
2 times area. Of
2 times area is base.
plus.
Plus.
Remember the base times height.
Okay, what information do they give us? What's the height?
The height is 10.
10 what?
10 feet.
10 feet. Okay. Now, what about the area of the base? Let's find that. How are we going to find the area of the base?
4 times.
Hold on. What kind of a thing is the base?
It's like a part of a square and part of a semicircle.
Oh.
Yeah, we've got a square and a semicircle, or at least certainly a quadrilateral, a rectangle, and a semicircle. How do we find the area of a rectangle or square? Length times width.
So it's going to be 16 right there.
Length times width plus, how are we going to find the area of the semicircle?
Pi r squared.
It's a semicircle.
Oh, yeah.
It's half of a circle.
So, multiply by 2 and then pi.
What? You just get?
Pi r squared divided by 2.
Yeah, something.
Yes?
Yeah.
Does this make sense? First we're going to do length times width. That'll give us the rectangle. Pi r squared divided by 2 gives us a semicircle. We add them together. All right, what are the length and the width of this rectangle? Yeah, it's 4 and 4. Okay. Plus pi, what's the radius? 2 squared over 2. Okay, what's 4 times 4? 16. What's 2 squared?
4.
What's 4 pi divided by 2?
2 pi.
2 pi, okay. 16 plus 2 pi. Perimeter of the base. We can't, notice you can't combine these. 16
Oh.
and 2 pi are not like terms. 2 pi, notice, is somewhere between 6 and 7. What's the-
Bro.
Because it's got a semicircle. So the area is not an integer. It's going to be some, for what? No, because it's pi r squared divided by 2 because it's only a semicircle. So the whole circle, if we had the whole circle, it would be 4 pi square feet. But here, since it's just a semicircle, it's only 2 pi square feet. Now, what about the perimeter of the base?
4 plus 4 plus 4
4 plus 4 plus 4, and then what about the curvy side?
plus 2 pi.
How'd you get 2 pi? But okay, we have to add what of the semicircle?
I mean, the radius.
You have to have the perimeter of it.
Right, we have to add the what do we call the perimeter of a circle? How do we find the circumference of a circle? Circumference is either 2 pi r or pi times diameter. Yes?
Yeah.
Okay, let's use 2 pi r because we already have the radius. But it's only a semicircle, right? So we don't want 2 pi r, we want a half circumference. Yeah, is pi r. Yes?
Yeah.
Okay, and what's the radius? Perimeter of the base?
12 plus 2 pi.
Okay, now we need to plug these things into our formula. Now this one's kind of annoying because we're going to have to do a bit more arithmetic because our area and our perimeter aren't just integers. So, how am I going to write the surface area? I'll give you a hint. Surface area equals...
16.
Nope.
That one.
2 times what? What do I need to write next after the times? What's the area of the base?
16 plus 2 pi.
So I need to make sure that the whole 16 plus 2 pi gets multiplied by 2.
We didn't multiply 16 times.
Okay, it's 2 times.
If I write this, what's going to get multiplied?
16 pi. Oh, no.
Only the 16 is going to get multiplied by 2.
Alright, so then
Multiply
16.
16 times 2, or add 16 to 2.
No,
I can't add them. They're not like terms. Unless I multiply out pi, but I don't want to do that. That's annoying. I'm going to use parentheses. 2 times, and there's the area of the base.
Oh boy.
Isn't that amazing?
Oh.
Because notice, it's just like one of these ones where we're translating from words into math symbols. First I find the sum, then I multiply by 2.
Oh my gosh.
Okay, plus what? What am I going to put in the second word? I'll give you a hint. Square bracket again. Perimeter of the base times height.
Perimeter of base. Parenthesis.
Yes.
12 plus 2 pi. Parenthesis. Times 10.
Times 10, yes. Notice, the area and the perimeter, they each have addition going on in them. So when I multiply, I need to make sure I put them in parentheses to make sure that the whole thing gets multiplied by that number. All right, so now what am I going to get when I distribute this 2 to the area here?
32 plus 4 pi.
Plus what?
120 plus 25.
Oh, yeah.
Okay, now what am I going to get when I combine my like terms?
24 pi.
Wow.
Yes,
152 pi. I mean, 152 inches.
152, what else do we have? 152.
Oh, it's not, I think it's meters now.
I wrote the unit on the board, it's also
feet,
in the...
feet.
What should it be? Square feet, it's an area, so square units.
Oh, it is there. Oh, it is there.
Bro, right there, why did you say no when I said 24 pi?
Last one, so you got some extra space there.
How's it squared?
How's what?
How's it squared?
What squared? The feet? A foot is a distance, not an area. This is surface area. Okay, anytime it's area, it's a square unit.
Okay.
Okay,
I say I'm smoking.
Where are you going?
all right.
I do.
Is there one more from the problem set that you want to go over or no? But please, with these geometry problems, make sure you know the formulas and you know how to use them.
You still let us get a quick peek at the test. So
This is practically a quick peek at the test. Or you look at problem set 40 is like a quick peek at the test.
okay.
The tests are like the problem sets, they're just shorter. That's all.
Just give us 20 problems.
The problems are not any more difficult on the test, generally speaking, than they are on the homework.
20 problems that we've done before, but from the problems that
Algebra, you should be able to do it on things that you haven't seen that exact thing before, but you've seen something similar. Turn to page 176. I want to talk quickly about lesson 44, which is not super complicated. And then after that, I'll open it up for 176. This lesson set will be due next week. Be due on, I guess, Monday. Let's quickly talk about adding fractions.
Adding fractions.
Adding fractions. If you don't know how to add fractions consistently, if I have something like 1 over 11 plus 2 over 11, how do I do that? How do I add 1 11 and 2 11s?
311.
Please don't use class time to clear out your.
311.
How'd you get 3 11s? That's correct. How'd you get that?
You just add the top ones and then cut the denominator.
Right. What if we have something though like 1/4 and 3/8. How do I denominator? Up here it was easy because they already had the same denominator 11. So I had to change these to get the same denominator. So instead of doing 1/4 plus 3/8, what am I going to do?
You multiply by the denominator by numerator by 2.
Yeah, I multiplied it by, really by 2 over 2. Yes?
Yeah.
What's 2 over 2 equal to?
1,
Oh, one.
1. What happens when I multiply things by 1?
you get 1.
What happens when I multiply things by 1?
You get 12.
I get the same thing. So it's the same thing, it's just in a different format. That's why I'm allowed to do this. Because I multiplied the top by 1. Yes, you paying attention? Maybe taking some notes? Maybe focusing on math and not cleaning out your bag? Okay. Now, this applies. The same thing applies to what we call rational expressions, which are algebraic expressions. 2/3 plus b over 3.
2 plus b over 3.
Yeah, 2 plus b over 3. Why am I allowed to do that?
Because you're math.
Mechanically, what would be 2b like?
No.
Because adding the
We
numerator.
said problem multiply.
When I have fractions, they have to have what in order for me to add them? The same.
Yes.
So what do I do to the numerators? I just add them. What's 2 plus b?
2b.
2. No.
Plus b.
2b is 2 times b. It's b over 8 plus 6 plus 2 over 8 plus 6. How can I combine these three rational expressions together?
Since they have all 8 plus 6 as the denominator, that you can add them all together, so you can make it like 8 plus 6 on the denominator. And then it's going to be 7 plus 8.
Yes, because they have the same denominator, they all have 8 plus, and then the 5 and the 2 combined because they're like terms to 7. It's possible to have some time at the end of the period you can do that. But really, this is kind of important at the moment.
More confident.
Okay, it doesn't matter how complicated what we have on the bottom or the top is. So let's do this one other example. We've got 5x plus 7 over 5a squared x minus 3x minus 2 over 5a squared x. Now, how am I going to combine these together? How am I going to combine these together? 5x plus 7 over 5a squared x minus 3x minus 2 over 5a squared x.
It's gonna be.
It's going to be 2x and then plus 5 on the top. And on the bottom is 5a a squared.
Right? They have the same denominator. What else?
Plus 5.
No.
Oh no, it's actually 2 minuses, so it's going to be 9.
Right? This is minus negative 2. Really what it is, this is on the top, we have 5x plus 7 minus 3x minus 2. So the negative sign gets distributed. 5x plus 7 plus negative 3x plus 2. So it's 2x plus what? 9 on top. 2x plus 9 over 5a squared x. The principle still holds, though, where as long as the denominator is the same, we just add the numerators. Yes?
Yeah.
Makes sense so far? This isn't something conceptually new. We're now just applying it to algebraic expressions using variables.
What about when the denominator?
What about when the denominators aren't different? Let's look at an example on page 177. What if we've got 3/4 plus 2 over b?
That b.
How are we going to add these together? Now, say it again. In order to add, what same denominator can we give to both of these fractions? Or another way of putting it is, what is the least common multiple of the denominators of these fractions? What is the smallest number we can multiply them both up to?
4.
B times what gives us 4?
4.
That's the least common multiple of 4 and
I mean 8. I mean like 8 under. Oh, sorry, over 4.
right. So the first one we need to multiply by b over b to get it to have 4b on the bottom, right?
Yeah.
We're allowed to multiply by b over b because b over b is equal to
1.
is equal to 1. Doesn't matter what b is, as long as it isn't 0. And then what do we have to do to 2 over b to get it to have 4b on the bottom? Multiply by 4 over 4. Okay, so how are we going to rewrite these? What's the first fraction going to become? 3b over 4b plus 8 over 4b. So now when we add them together, now they have the same denominator. What am I going to get as my answer? 3b plus 8 over 4b. There you go. Common multiple. Let's do a couple more. We're going to do this one, and we're also going to do this one. All right. Let's start with this one here. 4 over b plus 1 over c plus 1/2. We need to get them to have a common denominator. What's the common denominator going to be? Or what's the least common multiple of these 3 denominators? Because what's the least common multiple of these 3 denominators? 2bc. That's the least common multiple of these 3. 2bc. 1 over c is going to need to be multiplied by 2b over 2b. And 1/2 is going to need bc over bc. Okay, so what are my terms going to become once I do that? 4 over b is going to become what?
8c
Over
b 2b
over 2bc plus what?
2b
2b over
2bc
2bc plus
b. I can't read after that.
BC.
bc over. But that's okay because each time I was multiplied by what? 2c over 2c is 1. 2b over 2b is 1. bc over bc is 1. Yes?
Yeah.
Okay, now when I add, just like any other fraction, as long as the denominator is the same, I keep the denominator.
C
2a plus c plus 2b plus bc over 2b.
Bro, I bet you're
Right.
No, not.
Any fractions, as long as they have the same denominator, we can just add them by adding the numerators together. Now let's look at this one. N over c cubed plus 4 over c squared minus 6. What is the least common denominator of these 3 things? These 3 terms? No. The least, least common multiple. Least common denominator isn't even a thing. What is the common denominator?
If you make it easier, can you put like 6 over 1?
Yes! 6. That's all right. So what's the least common multiple of c cubed, c squared, and 1?
C squared, C cubed.
What?
C cubed.
So the least common multiple, the smallest thing we can multiply each one of them up to. It's easy to multiply c squared up to c cubed. It's easy to multiply 1 to anything. And c cubed obviously is already c cubed. So we want them all to have c cubed on the bottom. What am I going to do to the first term?
You're gonna do that.
I'm going to leave it alone. It already has the common denominator. What about the second one?
You're gonna multiply it by c cubed. So it's gonna be 4 c cubed over.
What do I do to c squared to get c cubed? No. Multiply by what? No.
Wait, c cubed, you gotta cancel it out. You get 4c.
Wait, no, you're gonna wait. Why wouldn't you times it by c over c?
Yes, by c over c.
That's what we said.
No, you said c.
By
By c over c. And then what am I going to do to 6 over 1?
multiply it times c cubed over c.
C cubed over c cubed. All right, so now what are my terms going to be? M over c cubed plus what?
C cubed.
Oops, sorry, c cubed. Plus what? 4c
over c cubed
plus, minus
6c cubed over c cubed.
Yes. All right, and then I combine them all together and I get?
Yes, m plus 4c minus 6c cubed over c cubed.
There you go.
Why do you do so many steps?
Because that's the way math
Just
works.
trying to show you guys in your head that's okay. But this step here is what we're doing to convert these fractions into. It's not due tomorrow.
Oh,
44, except for numbers
10 through 30.
3, 9, and 28.
3, 9, 28.
Let's say that we do Monday.
Do Tuesday.
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 Tuesday. Tuesday. Tuesday. Tuesday.
It was great.
Yeah, so you have to like review.
All right, fine.
Yeah. I'm not doing homework.
Do Tuesday. Do Tuesday. All right. Thank you very much.
Well, you told us, do you like to do that with them?